We jump to the Unit 4, Computer and Network. There will be two lectures on this. Okay, two lectures on this Unit 4, lecture 5 and 6. So today we're going to work on the computer, the lecture 5, Computer 1, okay? And number 6 is more on the internet, okay? So first, we want to talk about computer, and computer including computer software, hardware, and networking, three part, okay? Three part. So when we talk about computer issues, there are three part. Computer by itself, the software that helping it, and the network you connect. Okay, so network. Disk. This is software. Also hardware. Okay, these are three topics we talk about. And typically you need to know about parallelism, and then compare the delay of the different parallel computing model. Okay. And then part 2 is networking. Is more like on the OSI, okay, organization or standard international, something like that, okay. And then we will talk about layer 1 to 3 in this lecture, okay. So computing device is a physical artifact that can run a program. So including computer, tablet, server, router, okay, these are all computing devices. Apple Watch is also computing devices. And we have input and then processing, we get output. Okay, this is a typical idea of IPO, okay. So this portion I think is easy, the computer devices. So you know about your hardware and also the interface to the system, okay. Okay, we are at the age of the buts. Okay, so all kind of buts would be helping us. By the way, what is but? What is but? When people talk about but, what is but? So you may have chip but, native but. We are at one era of the but. So what really is but? Who know what is but? Jessica, what is but?
Like a robot?
Yeah, but for software, how do we say it?
Like a computer?
Usually it's a automatic software. We call it but. So but can be creating the so-called what is that? Service of denial service, DOS attack, okay? Distributed denial attack. So but is automatic a software agent from one server. Okay, we call it a but. And we are at the era of but, so all kind of robot, software but, okay, around. And you must know about it, okay? You talk about to some person in the AT&T, but they may not be a person. They may be a bot, okay? Okay, this is the bot. And we are living in the era of bots. There are tons of bots everywhere. So first one is computer organization. We have the keyboard, mouse, control unit, and memory. Let's look at some video, okay? First on this, what is computer?
Hi, I'm Nat. I was one of the original designers of the Xbox. I've been working with computers since I was maybe 7 years old, and now I work on virtual reality.
Computers are everywhere. They're in people's pockets, they're in people's cars, people have them on their wrists, they might be in their backpack right now. But what makes a computer a computer?
What does make a computer anyway?
And how does it even work?
As humans, we've always built tools to help us solve problems. Tools like a wheelbarrow, a hammer, or a printing press, or a tractor trailer. All of these inventions helped us with manual work. Over time, people began to wonder if a machine could be designed and built to help us with the thinking work we do, like solving equations or tracking the stars in the sky. Rather than moving or manipulating physical things like dirt and stone, these machines would need to be designed to manipulate information. The earliest computers were made out of wood and metal with mechanical levers and gears. By the 20th century, though, computers started using electrical components. These early computers were really large and really slow. A computer the size of a room might take hours just to do a basic math problem.
These machines are things of gleaming, vari-colored metal and numerous flashing lights.
Computers started out as basic calculators, which was already really awesome at the time, and they were only manipulating numbers back then. But now we can use them to talk to each other, we can use them to play games, control robots, and do any crazy thing that you could probably imagine. The computers we use today look really different from the earliest thinking machines. And who knows what the computers of tomorrow will be like? My hope is that you get to help decide what you want the computers of tomorrow to look like.
Okay, this is short introduction of what is computer. Just give you some idea of what is computer. The other video I think is not important. Okay, this one I would choose a different video from YouTube. Let me see. Let me try to find a short one. This one to the computer system.
Welcome to LearnComputerScienceOnline.com, and in this video, we are going to discuss a simplified introduction to the computer system. This video tutorial is specially designed for the beginners to learn the fundamental concepts related to computer. We will study the definition of computer, various components of computer system, important characteristics and features of computer, and how computer works. Let us start with a simple introduction to the computer system. A computer system is defined as a programmable electronics device that can be programmed to accept the input data, then process this input data as per the program instructions. The computer then presents the processed data to the user as an output. The user can utilize the processed data for some meaningful work. The computer system mainly consists of two types of components. The first type is called the hardware components, and the second type is called the software components. The hardware components are
right here, computer divided into hardware and software, okay? And software divided into system software and application software. And hardware divided into processor and memory. Okay, these are something you need to remember in the exam.
the physical parts of the computer, such as keyboard, display monitor, mouse, CPU cabinet, and other such parts. The computer system needs two types of software components to function. The first type is called the application software, and the second type is called the system software. The application software is directly used by the system user to perform different tasks on the computer, such as Microsoft Word and PowerPoint, whereas the system software is a special type of software that is internally used by the computer itself to manage and operate the various hardware components connected to the system. The operating system is the most important system software used by the computer. The operating system basically provides an interface to the user to interact with the system. Let us now understand the architecture of the computer system in terms of the functional units. The entire functioning of the computer can be grouped into various functional units. Let us understand some important functional units of the computer system with the help of a computer block diagram. The computer system working can be grouped into 4 major units. Each unit performs a specific function in the working of a computer. The 4 major units of the computer units are: first, input unit; second, memory unit; third, central processing unit, also commonly referred to as CPU, and the 4th unit is called output unit.
Okay, these are 4 unit parts you need to memorize. Okay, input unit, memory unit, CPU unit, and output input, I/O processing, and the memory. You have to memorize it. Okay, it's a basic 4 unit in the computer.
The input unit consists of various input devices connected to the computer system, such as keyboard, mouse, scanner. The main function of the input unit is to accept the data received from the input devices. The next unit is called memory unit. The computer memory unit consists of different types of memories used to store the data and the program instructions during the program execution. The computer uses different types of memories, such as disk memory, random access memory called RAM, cache memory, and the CPU memory registers. The next unit of the computer is called the central processing unit, and it is abbreviated as CPU. The CPU is also commonly referred to as processor or a microprocessor. The CPU is the brain of the computer and provides the processing power to the computer system. The main function of the CPU is to execute the computer program. The 4th unit of the computer is called the output unit. The output unit consists of various output devices connected to the computer system, such as display monitor, printer, projector, and other output devices. The main function of the output unit is to present the processed data by the computer. All right. So far we have discussed various functional units of the computer. Let us now move on to the next topic, that is, important characteristics of the computer system. The computer system has 4 important characteristics. These characteristics are: first, speed; second, accuracy; third, storage; fourth, fast decisions; and fifth, ability to perform repeated tasks. The computer can operate at very high speed. The computers can also operate with remarkable accuracy without any mistake. The computer also provides different types of storage devices to store the large volumes of data. The processor inside the computer is designed to take fast decisions as per the program instructions. Similarly, the computer can work continuously and repetitively perform the programmed operations without any break. Let us now move on to the next topic, that is, important features of the computer system. The computer system has some important features. These features are: first, the computer is a programmable. The term programmable means each task performed by the computer is directed by the set of instructions. This set of instructions is called as a computer program. The computer program directs the computer system to perform specific operations. In other words, the computer will perform the task only as per the program instructions. Second, the computer is used to process the data. The data processing is one of the most common use of the computers. The computer processes the raw data and produces the information. The data cannot be meaningfully used in the raw form. The raw data needs to be first converted to processed data so that it can be used for some meaningful work, such as decision-making within an organization. Third, the computer is digital electronic machine. The computer is called a digital electronic machine because it contains electronic.
Any question on this one so far? Any question on this one so far? Any question on this one so far?
No.
So what are these binary, Abby?
It's like ones and zeros, and then if it's zero, then it's like off, and if it's one, it's on.
What are these used for the computer?
It's like numbers or like switches.
There are switches, and then why we need switches?
To like know when like some things should be like turned on or off, or like, yeah.
What about Alex? Why a transistor is used by CPU?
Well, isn't it to like tell it when a certain like current
Hmm?
should be? Isn't it when a certain current should be flowing through it, so certain
Mhm.
processes can take place?
Hmm. So what are the importance of these transistors?
Uh,
The transistor is the basic computing unit. All the CPU or other functional blocks are built upon these transistors. Okay.
Components, and computer needs an electric current to operate. The term digital simply means the computer understands the language of only 0 and 1, called the binary number system. The computer can understand and execute instructions written only in binary. These instructions are called machine instructions. The machine instructions in binary consist of only two numeric numbers, that is either 0 or 1. The CPU can execute the program instructions encoded in machine language. The machine instructions consist of sequence of only two numeric numbers, that is, either 0 or 1. The binary code is also referred to as machine code or machine language. The computer's microprocessor works as a brain. The processor performs all the arithmetic calculations and also handles the logical operations. The program compilation is another important fundamental concept related to the computer that you should be aware of. The computer programs are written using any high-level, human-readable programming language such as C language, Java, and Python.
So what is the purpose of the CPU then? So far you heard something. Okay. How about Banani? What is the purpose of the CPU? Hi, Banani, hear me?
To
What's the purpose of the CPU?
to run the operating system.
No, what are we talking right now? To run all the instructions from the program, okay? Must pay attention. Right now we're talking about program converted to the binary code, and then binary code are instructions sent to the CPU, and CPU need to run it. Okay.
However, the computer processor can decode and execute instructions only in machine code in binary. So, it doesn't really matter in which high-level programming language you write the program code, because eventually, all high-level computer programs must be first converted to low-level machine code in binary. That's CP.
What is a high-level language? This one for Alex. What is a high-level language?
Isn't it like, um, isn't it just like, because our coding is low level language, so
Hmm?
high level language, isn't high level language like something the computer reads?
No. You finish APCSA, you should know it. Okay. Jessica, what is a high-level language?
Is it like a programming language?
What kind of programming language?
Like the ones on the side?
No. I'm asking what is high-level language? These are examples, but not the definition of the high-level language. Same thing, you finish APCSA, you are supposed to know it, okay? AB, what is a high-level language?
Uh, I don't remember.
You don't remember. What is a low-level language?
Does it just use like binary stuff? Or like
How about Natalie? What is high-level language?
It's like a language that uses another language.
None of you know about high-level language. That's actually terrible. Okay? You are learning APCSP or okay, no matter what APCSA or APCSP, you don't know what is high-level language. High-level language is a language that programmers use, and it is English-like because they don't want to make the language too much away from the habit of the human's reading capability. So they design a high-level language, and then the high-level language need to be translated to low-level language or machine-level language so that computer can be used. And what is low-level language? Low-level language means the machine code, the instruction set that designed by the CPU, or the assembly code that is actually have the one-to-one mapping from the machine code. Those are low-level language. So low-level language actually is less readable, but is the real language that being run by the computer. High-level language instead is actually human-like language that used to do programming, and it's not as low level, so they need to have a converter or translation in between. Okay, must remember this. Okay, this will be tested.
You can directly execute. The compiler is used to translate the high-level program into low-level machine code in binary. This conversion process is called the program compilation. For more information on this topic, please read the detailed article on our website, learncomputerscienceonline.com, for more details. All right, that brings to the end of this tutorial on Introduction to Computer System and some its important features.
Okay, this video you must watch again by yourself later. Okay, apparently you don't know. Most of you don't know about what is these computer language assembly. The concept will be tested in APCSP, okay? Okay, this one show you what is the CPU and then how it works and how the computer system works. Okay. Next one, let's look at another one that's called CPU and TPU and GPU and CPU, TPU. These are different processors on computer. Let me see. I'm not sure this is good or not, but let's try this one.
With Capital One's top-rated apps, you can access your accounts on the go. Shop online without exposing your actual card number to display the perfect pair. Plus, get alerts you can count on. Shop and bank confidently with Capital One.
It's important to understand that when it comes to the basic functionalities, CPU, GPU, and TPU can do all of the same thing for the most part. The difference comes in how fast and how well each one of these is able to perform our machine learning tasks for us. The CPU is the general purpose processor that we all know and love today based on the von Neumann architecture that is found in every computer. It has great flexibility, which means that it can be used with many applications. But when you're dealing with CPUs, the hardware of a CPU doesn't know the next calculation until it reads the instructions. In neural networks, we know that many calculations are predictable, but the CPU needs to first read the instruction, execute them one by one, and access the memory every single time, and that results in a low throughput. So if you have quick prototyping that requires maximum flexibility, the CPU is the way to go. Or if you have simple models that do not take long to train. Alternatively, if you have small models with a small effective batch sizes. With models that are dominated by custom TensorFlow operations, which are written in C++, or with models that are limited by the available I/O or the networking bandwidth of the host system. Now, GPUs, in contrast to CPUs, use thousands of ALUs to execute huge computations in parallel, such as matrix multiplication in neural networks. GPUs also suffer from the same problems as CPUs since it's still a general purpose processor, which is not only used for matrix multiplication. For every set of calculations, it has to read instructions and access memory, which increases complexity. GPUs are still very good for usage on the following use cases. So if you have models for which the source does not exist or is too onerous to change, GPUs are good for that. Or if you have models with a significant number of custom TensorFlow operations that must run at least partially on CPUs. Or if you have models with TensorFlow operations that are not available on Cloud TPU. And lastly, for medium to large models with larger effective batch sizes. Google designed Cloud TPUs as a matrix processor specialized for neural network workloads. TPUs can't run word processors, control rocket engines, or even execute bank transactions, but they can handle massive matrix operations that are used in neural networks at really fast speeds. The primary task for TPUs is matrix processing, which is a combination of multiply and accumulate operations. TPUs contain thousands of multiply accumulators that are directly connected to each other to form a large physical matrix. This is called a systolic array architecture. No memory access is required during the matrix multiplication process. As a result, TPUs can achieve a high computational throughput on neural network calculations. TPUs are good for the following scenarios. So if models are dominated by matrix computations, TPUs are the way to go. Or if you have models with no custom TensorFlow or PyTorch or JAX operations inside the main training loop. Or for models that train for weeks or months at a time. And lastly, for large models with large effective batch sizes.
Okay, this one explain what is GPU, what is CPU, what is TPU. So let me rephrase it a little bit. CPU is a central processing unit. Okay, so its purpose is like inside a CPU, you have something called a loop. And you also have something called control unit. So control unit give commands ALU is arithmetic and the logic unit. We call it ALU. Okay, so basically you have a C control unit here, and you have the ALU take in two variables from A and B. Okay, you can choose to be plus, minus, or time, okay, or division, and get the result. And the result may write back to your memory. So what this CPU really do is like they will execute instruction after instruction. So instruction, integer add A with B, okay, and then save A to memory location. So it's something like this. You have instruction by instruction done by CPU. So CPU main job is to run instructions. That means it's used to interpret the program, your machine code program. So far, okay? My banana is okay?
Yeah.
Any questions so far? And we are going to cover the GPU. Okay, next one, let's talk about GPU. So you have a CPU, you run the program, actually getting the instruction and the data from memory. So every time you load the data to CPU and run and get the result. So let's assume that we have A equals 3, B equals 4. It got loaded to register A equals 3, register B equals 4, and then calculate to generate register 3, C equals 7, and then 7 ship back to the program. Okay, so that's how CPU work. But doing this, you fetch memory and the instruction by instruction from the memory. That's actually too slow. So people invented GPU. Especially they are doing a lot of matrix operation. So use a GPU to control GPU. And GPU become a floating-point computing engine, and then also allow graphic operator can be solved easier. Any questions so far? Any questions so far? So GPU means graphic processor. A graphics processor means that you deal with the graphic information such as image or game photos. Okay. And then if you involve intelligence, you might want to have another one called neuron processing unit, okay, or something we call it TPU. So some special designed hardware for neural network, we call it neural processing engine or TPU, okay. So these are the three processors difference. Okay, that's good. Let's go back to our slices. So that's the CPU. Next one you need to know about, there is a sharing of the operation system and the user system. So let's look at what is operation system and what is the software system, software application. Okay, let's look at what is the system software.
We have a problem that we work on. We break it down into pieces.
Welcome to LearnComputerScienceOnline.com, and in this video, we are going to discuss what is a system software, types of system software, and its functions. But let us first understand what is a software, and then we will discuss what is a system software. The computer system consists of both hardware components and the software components. A software is essentially a computer program that consists of set of program instructions. These program instructions are loaded into the main memory of the computer to start the program execution. The microprocessor, also called as a central processing unit, CPU, is the brain of the computer. The CPU fetches these program instructions from the main memory RAM, one by one. These machine instructions in binary can be decoded and directly executed by the microprocessor to perform various operations as per the program instructions. In other words, the software is an essential component of every computer system. Okay, so far we have discussed what is software and why do we need software. Let us now understand different types of software used in the computer system. The computer system essentially needs two types of software. The first type of software is called the application software, and the second type of software is called the system software. The application software is used by the computer user to perform various tasks on the system. For example, Microsoft Office is one of the most commonly used application software. Whereas the system software is internally used by the computer system itself to communicate with the various hardware components. In other words, the application software works as an interface between the user and the computer system. And the system software works as an interface between the operating system and the computer hardware. The hardware components can either be internal components that are part of the system itself or some connected externally. For example, some hardware components, such as keyboard, display monitor, and mouse, are connected externally to the system. All right, let us now discuss in detail our main topic, and that is, what is system software? The system software is also alternately referred to as system program. The system software are computer programs developed specially to operate various hardware components connected to the computer system. The operating system itself is a type of system software. The operating system is an essential component of every computer system and the first system program that gets loaded into the memory each time the system is powered on. The user can operate the system only after the operating system is fully operational. The operating system is responsible to manage and control all the system resources. That includes all
Okay, so
hardware.
system software is Windows, Mac OS, Linux. So these are all operation systems. Their purpose is to manage all of the resources, hardware or software. No matter it's a hardware or software inside your computer. So hardware, like the use of CPU, the use of GPU, how much time you will be attributed. You will get the share of the running of the CPU, depending on this operation system. Same thing for the software, your email server, your file transfer protocol, they all controlled by the operation systems. So operation system manage everything, including hardware and software.
And software components. However, the operating system internally use another set of system software components to communicate with the different hardware components. The hardware components are physical parts of the system, which we can see, and these components are physically connected to the system. The computer user does not directly interact with the system software and other system software components that are internally used by the operating system to drive various hardware components. Okay, let us now take a quick look at different types of system software used by the computer system. The system software can be grouped into two main types. The first type of system software is internally used by the computer system for the management of the computer system itself. On the other hand, the second type of system software is used by the programmers and the software developers for the development of the software. The first type of system software include the operating system, device drivers, BIOS, UEFI, used to boot the system, and other system utility programs, such as antivirus software, used to clean the system, and the disk compression and disk cleaners. The device driver is system program internally used by the operating system to drive different internal and external hardware components. The second type of system software include programming languages for writing the program code, program compilers, and interpreters that translates the high-level program code into the binary low-level machine code. All right. That brings us to the end of this video tutorial, and in this tutorial, we have discussed in detail what is system software, different types of system software, and its functions. Please visit our website, learncomputerscienceonline.com, to learn computer science online. If you have liked this video, then please give us a thumbs up, and
Okay, so system software is like Windows. Okay, like Windows. So no matter it is your CPU, okay, your GPU, okay, your I/O devices, okay, these are inside your CPU, GPU, and also your memory system, okay, everything is managed by the operation system. Okay, such as Unix, Windows, or Mac OS. Okay, these are operation system. And then on top of operation system, you do have a compiler and everything. So your application talk to the compiler and everything talk to the system software. So this is what system software is. So without system software, your none of your program will work. Now let's look at another topics like okay.
consider subscribing to this channel. Thanks for watching, and I will see you soon with another computer science tutorial.
Next one is what is application software?
Welcome to learncomputerscienceonline.com, and in this video, we are going to discuss what is an application program. The application programs are also alternately referred to as software applications. The application programs are computer programs developed specially to provide specific functionality to the user. The application programs are an essential component of every computer system. The application programs essentially provides various functionality to the computer user to perform different tasks on the computer system. For example, you may be writing a document, or emails, or watching a movie, or listening to the music, or managing the accounts. For all these applications, you will need an software to use the computer for any such job. And therefore, large number of software applications are developed by the software industry. The software applications can either be a general purpose software, or it can be specially designed as per the requirements of a specific business corporation. The business corporations also invest sizable money for developing the software application to manage and support the business operations of the company. Let us now understand in detail what is application program and how it works. Each computer system broadly consists of two types of components. The first type of components are called the hardware components, and the second type of components are called the software components. The hardware components are physical parts of the system, which we can see, and these components are physically connected to the system. Whereas the software components consist of set of instructions to perform various tasks on the system. The application software also provide an interface to the system user. The software components are required to control and interact with each hardware component in a computer system. The application programs are used by the user to interact with the computer and to provide a specific functionality to the user. Some of the most commonly used application software include Microsoft Word, Excel, PowerPoint, and also media players, which all use to watch the movies. For example, we use application programs like Microsoft Word to create the Word documents. Similarly, we also use Microsoft Excel to create the spreadsheets for managing the data in the tabular format. The media players are another example of the application software used to watch the movies and other video files. Another example of application software is the commonly used email software, such as Microsoft Outlook Express. The web applications is another category of application software that we often use through an internet browser. The web applications can be accessed using any internet browser, such as Google Chrome, Mozilla Firefox, Microsoft Edge, or any other internet browser program. The web application is a special category of application software that are based on the remote web server rather than on your local computer. The web applications can also be developed using any programming language. However, for web application development, various frameworks are available in the market that are based on specific language and technology. These frameworks provide a skeleton for the web app and simplify the development process. The mobile applications is another category of application software that are specially designed for the mobile devices. These applications are popularly called as Android apps. Let us now talk about the application software development. The application programs are designed and developed by using any high-level programming language, such as C++, Java, Python, or any other suitable programming language. Similarly, the mobile apps can also be developed using different programming languages. And that depends upon the operating system and the platform, such as Android or iOS-based Apple devices. Let us now summarize what is application program. The application programs are software applications specially designed to provide various functionality to the computer user to perform different tasks on the computer system. That brings us to the end of this video tutorial, and in this tutorial, we have discussed what is an application program, or a software application. Please visit our website, learncomputerscienceonline.com, to learn computer science online. If you have liked this video, then please give us a
Okay,
thumbs
this
up.
application software. So we give you the idea of what is system software, what is application software, and usually in the exam, they'll test you this in the application what will happen, and or in the system software what will happen. So you need to differentiate them. So now let's look at work on one thing. Okay, here let's look on one thing. So right here, I do have a disk that has a bed sector broken. I want to fix it using VCheck. So VCheck will check if the disk is bad or not. Okay. So in this case, this VCheck is system software or application. This one for AB.
Uh, uh,
A software to check the back sector of the disk. Is that system software or is that a application software?
is it system software?
Yes, this is system software. Somebody have a class and playing room. Talk to another person online. So is room application software or system software? This one for Banani. Zoom.
Um, application.
It is the application on top of the OS Windows. Okay, that's correct. That's an application software. But by itself, it actually set up the system work for the room by itself, working at the behind for the sessions control for your video conferencing. Okay, so in a way, if you call it a system software, it should also be fine. Okay, so what I want to say is that if you are Windows, you believe that yourself is a system software, but somebody provides service for someone else, they may call themselves system software. Okay, but in fact, this will be an app in Windows. Okay. Okay, I just can give you some small test. Okay, making sure you understand what is the system software, what is actually what is the system software? So you need to know about system architecture. Okay, this will give several examples. Okay, instruction set architect. Okay, this one a little bit complicated, but let's actually look at the video. ISA. Okay.
Ready to be an e-commerce pioneer? Our baked-in premium plugins give you the best.
Welcome to LearnComputerScienceOnline.com, and in this video, we are going to discuss what is an instruction set architecture. The instruction set architecture, abbreviated as ISA, and it is a part of the processor architecture. The instruction set architecture basically works as an interface between the hardware and the software. In simple words, the instruction set architecture is defined as the entire group of commands that the processor can perform to execute the program instructions. Every processor design is based on one specific instruction set architecture. The instruction set architecture only defines the operational capacity of the processor in terms of set of commands that the processor can decode and execute. For example, the Intel 8085 instruction set architecture consists of total 246 operation codes and 74 instructions. Let us now talk about how instruction set architecture is implemented into the processor design. The processor architecture at the hardware level is also referred to as microarchitecture. The term microarchitecture is defined as the actual hardware implementation of the instruction set architecture. In other words, the microarchitecture is the hardware circuitry of the processor chip that implements one particular instruction set architecture. The instruction set architecture does not specify the actual implementation details of the instruction set architecture. And therefore, the chip manufacturing brand can decide how to implement the instruction
Okay,
set.
so instruction set architecture means that we provide a programming interface to the hardware. And then here we have Intel i5, i7, i9. Okay, they are of different clock and speed. But when you program them, they are the same device. They're just Intel instruction set architecture compatible, x86 compatible. That means your program, no matter it's written in i5 or i7 or i9, it will look the same. So you don't need to worry about your program will run on i7 but not on i5. Okay, as long as the Intel processor is x86 architecture, even you move on to AMD CPU, they should work because their instruction set is the same. So instruction set architecture is a set of rules that you to design your programs. So they are instructions, Intel instructions, and those instructions will be run by the hardware, and the hardware may be run at a different speed, but the software remain the same. That we call it instruction set architecture. Okay.
That architecture into the processor microarchitecture design. And for this reason, the two different processor brands that are based on the same instruction set architecture can have different implementation into the processor microarchitecture. All right, so far, we have defined and understood the concept of the instruction set architecture and how it is implemented into the processor microarchitecture. Let us now briefly discuss some other important fundamental concepts related to the processor architecture and its correlation with the instruction set architecture. The instruction format is another important design concept that is part of the processor architecture. The computer program consists of a set of instructions which directs the CPU to perform some specific operations. However, we all understand that the computer can execute only low-level machine instructions in the binary format. And therefore, all high-level programs are first compiled with the help of a special software called the compiler. The compiler translates the high-level program instructions into the low-level machine instructions in the binary format. The instruction format basically defines the layout of the machine instruction in terms of operation code, operand, and the addressing mode. The instruction format supported by the processor depends upon the instruction set architecture of the processor. And therefore, the processor can support the instruction formats that are compatible with its instruction set architecture. Let us summarize. What is instruction set architecture? The instruction set architecture, abbreviated as ISA, is a part of the processor architecture. In simple words, the instruction set architecture is defined as the entire group of commands that the processor can perform to execute the program instructions. All right, so that brings to the end of this tutorial on what is instruction set architecture. In this tutorial, we have discussed in detail some important.
Okay, we finished instruction set architecture. Okay, so every day we run computer. So how can I know one computer is compatible with another one or not? So this ISA instruction set compatible or not would be very important. So when you go to Python site, you try to download your code, right? You go to install your Python. So that's as soon as you want to go to Python download site. Okay, you look at the Python download site. Here, okay. Different version. Let's jump to different version. Okay, I'm sorry, not this one. Let me jump to this 3.118. Okay, whatever this one. So inside here, let me see. Okay, I do have this different one. So I do have Windows 32-bit, 64-bit, ARM64, Mac OS. So at least this different one. Okay. So instruction set architecture would be this one. You may have the Mac OS 64. That's one kind of instruction set, Mac OS 64. Another one is Intel 32-bit. That's one architecture. And Intel 64-bit. So Intel 32-bit and 64-bit are not compatible. They are separate different processors. Windows ARM64. That's not compatible with either one as well. So this is another instruction set architect. So this actually show you 4 versions of the instruction set architect. Is that okay? Alice, is that okay? Hello? Hi, Jessica, is that okay so far?
Yeah.
So, Jessica, if you go to buy a Mac OS, you're buying a computer Mac notebook that will be Mac 64 instruction set architect. Can you download the Intel processor's Windows installer to run it or no?
No.
No, because your CPU is different, so your instruction set is not compatible. Okay, so from here you know that which instruction set you are using. Okay, from here you know which instruction set you are using. This is instruction set compatible. So we talk about this difference. There is a instruction set compatible issue. Okay. Okay, that's actually erase it. That's instruction set. So here we go through so far several things. Application software, okay, and then we go through the so-called system software, okay. We also go through what is CPU, okay. We also go through what is GPU, okay, and we also go through what is instruction set architect. Next one, we are going to talk about parallelism, okay, parallelism. So parallelism is how we can run things parallel. But there are different level of the parallelism. Okay, the parallelism just means that can we do things in parallel or not? So parallelism including different parallelism. One is task level. One is functional level. Another one is instruction level. Okay, nowadays we want the computer to run faster and faster. So we need to utilize the parallelism. Means that one task you may want to run with another task. So actually 2 tasks are running at the same time. We call it parallelism. Okay. So let's look at the video for the parallelism. Okay. Okay, let's use this simple one.
Next. Stop. We got it?
Hey guys, and welcome to another video from Fast Tech Skills series. In this video, I'm going to talk about a very interesting concept, which is parallel computing. This topic, or this way of computing, I should say, has been very, very popular in the past years. And there's a specific reason why, which I'm going to discuss in this video. But let's have a look at traditional computing, the type of computing which is not parallel. So we have the processor here, and the instructions come in and the processor does the processing, and then you have the process data here. As you can see, there's a queue of new instructions coming in, and the processor is doing its job, and then we get kind of process data out of it. Now, there's a problem with this approach, especially in the past couple of years, and the problem is that we can only make this processor faster to a limit. There is a frequency limit, and the reason, there are plenty of reasons actually, but one of the important ones is heat, because these processors are very, very condensed. So the amount of heat generated by electrons moving through the processor is very, very high. And that's one of the reasons why we can't really increase the speed of processors, one single processor, because it will melt down. So because of this reason, we had to take a different approach. So if we want to increase the speed, but we can't really increase the speed in one single processor because of heat, then what can we do? So one thing we can do is increase the number of processors. This way, we have two processors running simultaneously, and we divide the tasks between these two processors. This is called parallel computing. Two processors running at the same time, doing the calculations, and we divide the workload between these two processors. Of course, this introduces a new set of potential problems, and one of them is more bugs, because you should know when first which instructions you need to divide and what instructions need to be dedicated to each of these processors. Because let's say that you assign kind of a process to this processor here, and that task gets done fast, but this task is dependent on a process which is currently being run by the other process here. So you can have a kind of latencies, you can have a different kind of problems when it comes to writing programs for parallel systems. Of course, majority of computers, especially since past couple of years, all the computers are running on multi-core processors. So that's another thing. Each processor in the modern computing is called a core. So a quad core, a dual core, that's basically, that explains the number of processors running at the same time. So this is a very, very short video on what parallel computing is. We also have distributed computing, which is the subject of another video. Thanks for watching this video.
I'll tell you what is a parallel processing, okay? And next one we will look at is what is the core and what is the thread, okay? So we hear the word core and thread. You may heard the word core and thread before. Okay, and thread. So you may buy a computer and you say your CPU is a quad-core core. Quad-core means that the computer has a 4 processing unit, share same memory model. So at the same time, 4 programs can be running individually. That's called quad-core processor, okay? So optimally, you can reach the performance of 4 times, but in fact, no. Usually, there are data dependencies or some other issue. So the performance cannot always reach 4, okay? So another word that's called thread, okay? So core we know is hardware. It's called core. The other word is called thread. And we may sometimes call it multi-threading. So that means that you run and you fork two threads. So two threads run each other, and then this run two threads each other, and then at the end they all combine together to one single thread. So to separate processing, we call it fork. To join back, we call join. Okay, it's called multi-threading. So on one CPU, you may also use a multi-threading to allow the computing to be parallel. So 4 processors may have 16 threads running at the same time. This is called multi-threading. Okay, this is called multi-threading. Okay, this is multi-threading. Let's go back to the slides. Okay, so one CPU can run one thread. One CPU can run multiple threads. 2 CPU can run each one thread. That's called multiprocessing. Okay. Middle one is multi-threading. That one is single threading. Okay. You must know about it, sequential processing and parallel processing. So in an exam, usually they have problem like this. Okay. Other than that, this portion is fine. Okay. And the application software and the system software, we already talked about it. Okay. So let's have a break. And after break, we are going to start to look at the 7-layered architecture, the lower 3 level. Okay. So now it's 11:12. Let's break to 11:20. Okay. We will start to look at internet. Hello, we are back. Any questions so far?
No.
No. So for AB, what is the purpose of the CPU?
It's for like processing things,
What kind of things?
or like instructions and stuff.
Instructions. Okay. How about Alex? What is parallelism?
Sorry, what?
What is a parallelism?
Oh, like being able, so like splitting the instruction into two different cores, so you're running two things at once.
Running 2 things at the same time. Okay. So one Jessica. Okay. What kind of software is application software? Hi Jessica, how are you? Hello? Hear me? Hi Jessica, hear me? Hello?
Yeah.
What is application software?
It's like what the user uses on the computer, and it does
Mm.
like
It opens apps and stuff to do tasks.
Next one, Manelli. What is a system software? Hi, Manelli. What is a system software? Hi, Manelli. Hello? Hear me? Hello? You may mute yourself. Hi, Manelli, hear me? Hello? Manelli, do you hear me? Hello? Hi, Manelli, do you hear me? Okay, I keep up. Next one, Natalie. What is the system software?
It's like different computer programs with like that go together,
There's no different program to call it together.
like separate computer, like one.
No, system software is the software that manages the resources, hardware or software on computer, okay? Such as Windows. You can remember them, okay? Okay, just a short test, making sure you understand the topic in the computer section. Next one, we are going to move on to the networking section, okay? So computer, sometimes we call it C&C, computer and communication. So computer and communication, your computer cannot be standing alone. You need to talk to another computer. Once you talk to another computer, the network being formed. Okay, the network being formed. So because two computers may be different vendor, one may be IBM, one may be Dell. So there's some standard need to be in between for the two computers to talk. And the standard, we could call it protocol. So protocol is a set of rules that cover the execution of the data transmission between computers. Okay, so these are some terms you need to know before we get started. So one computer talking to another computer, that's called one network. Okay, that's called one network. So now if you have a building and you have Wi-Fi and you connect several computers together within the building, then we call this one intranet. Okay, and you have one network, so there are multiple computers connecting together. So if there are many, many different buildings, they all connected together. This connection, we call it internet. It's a network between networks. Okay, it's a network between networks. So this 7-layer architecture is to talk about these different networks, how they work, okay, how they got organized, and how they function. Okay, we need to talk about it now. So that's they have a standard of 7. So these different terms you need to remember. What is HTML? What's HTTP? Okay, these are basic terminology you must remember. Okay, ASCII code, abstraction protocol, special protocol. Protocol is a set of rules governing the exchange and transmission of data between devices. You must remember them. Okay. Okay, 7-layer architecture. So the internet being formulated so that they have 7 layers. And top 3 layers are software layer. They just change of softwares. There's no real device or boxes or computer or switch boxes to work for it. The lower 4 level may have boxes to do it. Okay. That may be a modem, that may be a phone, that may be a computer. Okay. So top three are applications layer, presentation layers, session layer, transport layer, network layer, data link layer, and the physical layer. Okay. So let's look at one video for this 7-layer architecture.
OSI stands for Open Systems Interconnection and is a conceptual framework for how applications communicate over a network. There are 7 layers within the model, and the layer's depiction is used to help users identify what is happening within a networking system. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new RealPars videos. This way, you never miss another one. The OSI model layers are typically described from the top layer down. The layers are described as application, presentation, session, transport, network, data link, and physical. These layers are provided by a mixture of network card drivers, operating systems, applications, and networking hardware that facilitate the transmission of signals over Ethernet, fiber optic.
Okay, they always exist together. Okay, they always exist together, but the lower 4 are more hardware, top 4 are more software. Okay, must remember that. Okay.
Optic, Wi-Fi, or other wireless protocols.
Okay, on the right side, we have the 3 pair, optical, and Wi-Fi. These are 3 kind of medium. Okay, medium. That means the video, the internet can be running on Wi-Fi or 3 pair cable or Wi-Fi cable, Wi-Fi. Okay, these are communication medium. No matter which one helps us to transmit data. Okay. You need to pay. Okay, you need to pay to get access to it. Okay. Anyway, let's get started. Okay.
We'll describe the layers from the top down, as the top layer is the application layer, or layer 7. This is the layer that most users interact with and will recognize. The application layer provides network services to the end user. These services are protocols that work with the data the client is using. One of these protocols may be HTTP, that is used with web browsers such as Google Chrome, Firefox, and Internet Explorer. Other examples of applications that use this layer are Office, Outlook, and Skype. All of those interactive applications provide a set of services.
Okay, you can see that here Skype, Zoom, these are all applications. Okay. And they are some software. Sometimes they have an individual app by themselves. Okay. So you can see that. Okay.
That allow the application layer to supply data to and receive data from the presentation layer. The presentation layer, or layer 6, performs the uncomplicated task of syntax processing, or converting data from one format to another. For example, consider you're ordering something from an online store. These transactions are typically handled in a secure transmission, which means that the data passing between the store or the website application will transmit encrypted data to the presentation.
Okay, so layer 6 is responsible for the encryption, keeping the data secret. Okay, finding the address, those kind of things. Okay.
Layer that will need to be decrypted and processed. This layer handles translating the data from the top layer, which is presented in application format, to network format, and vice versa. After the presentation layer processes the data from one format to another, the information is then passed to the session layer or the application layer, depending on whether the data is transmitting or receiving. At the session layer, or layer 5, the construction, direction, and conclusion of connections between devices occur. This layer supports multiple types of connections, as well as being responsible for authentication and reconnection if a network interruption should occur. After the session is established, the data then passes to or from the transport layer.
Okay, let's roll back a little bit to the session layer. So this is session layer is just like you log into Citibank website, and then you may idle there for 3 minutes. And if you are idle for 1 hour, they may kick you out from website to make the website secure. Okay, so session control is control the dialogue between the laptop and the server. Okay, so session layer's job is to actually make sure that session is in whole still be working on, making sure that the transmission is smooth, data got assembled correctly, those kind of things. Okay, also if someone log out, happen have a log out, but just the browser drop a little bit, you'll come back with the same cookie and then still be running. Okay, those kind of issues.
Types of connections, as well as being responsible for authentication and reconnection if a network interruption should occur. After the session is established, the data then passes to or from the transport layer. The transport layer, or layer 4, is responsible for the transmission of data across network connections. This layer coordinates how much data to send, how fast, where it goes, and these sorts of things.
Okay,
Of the
so layer 5 decided that data should be going. Okay, you should go. That's okay. Layer 4, as for the data, how they go to the destination, is the shipping department's job. So transport layer is the shipping department. Okay, they kind of handling that. Okay, this whole thing is too big. Let's chop to the smaller chunk to send it. That we call it package. To send through the network, okay? And when they arrive, we actually sample them back. So the transport layer is very busy. It's more like a mail office or something, okay? It actually keep sending and receiving data, okay? And they can chunk the data from big box to smaller one, okay?
Known protocols for internet applications, these services may be provided by Transmission Control Protocol, or TCP, and User Datagram Protocol, or UDP. Other protocols may provide additional capabilities, including error recovery, data flow, and retransmission. Once the transport layer has completed its function, the data is then passed to or from the network layer.
Okay, one stop. So there's a TCP and UDP, two kind of the protocol in transport layer. TCP is reliable. When you miss some data, they already transmit. Okay, UDP is not. UDP, if you drop data, that's it. I don't care. So usually UDP is used for video or audio or speech transmission, and TCP for text or safer keyword transmission. Is that okay so far? Hello, is that okay so far?
Yeah.
Regarding the TCP and UDP, okay? Okay, let's continue. Right here, I just want to give you some overview of the 7-layer architecture.
The network layer, or layer 3, handles the routing of the data. After the data arrives at this layer, each frame of data is examined to conclude if the data has reached its ultimate target. The layer sends data to the correct destination on outgoing transmissions and receives incoming transmissions as well. The IP portion of TCP/IP is the commonly known network layer for the Internet. This layer also manages the mapping between logical addresses and physical addresses. For IP addresses, this is accomplished through Address Resolution Protocol, or ARP. The data is then passed to the next required layer, which is the data link layer. The data link layer, or layer 2, is considered the most complex of the layers.
Okay, go back.
This layer also manages
Network layer is computer to computer transaction communication. Okay, data link layer is board to board, one connection board to another connection board communication. Okay, and physical layer is wire to wire model. Okay.
The data link layer, or layer 2, is considered the most complex of the layers. This layer is often divided into sublayers called Media Access Control, or MAC, and Logical Link Control, or LLC. The layer sets up links across the physical network. When this layer receives data from the physical layer, it checks for transmission errors, and then packages the bits into data frames. From there, this layer manages the physical addressing methods for the MAC or LLC layers. An example of the MAC layer includes 802.11 wireless specifications as well as Ethernet. At the data link layer, the data passes to or from the final layer in the OSI model, which is the physical layer. The physical layer, or layer 1, is the electrical or physical layer of the model. This layer encompasses the network cables, power plugs, cable pinouts, wireless radio frequencies, connectors, transceivers, receivers, repeaters, pulses of light, electric voltages, etc. When troubleshooting problems, this is typically the first place to start. Is the device plugged in? Is the wireless card working? At this layer, the model transmits the digital data bits from the source or sending device's physical layer over network communications media, which can be electrical, mechanical, or radio, to the receiving or destination device's physical layer. The OSI model is a guide for developers and vendors to smooth the progress of developing communication products and software programs that will work in cooperation with a commonly established model. Once you understand the model, you can then understand which protocols and devices will be compatible with one another.
Okay. So here we finish.
Want to learn PLC programming in an easy to understand format?
Okay, so we finished these OSI models, okay? And then today we may end here, okay? We are already more than 1.5 hours. Next week, we will be focused on 7 layers and explain each layer how they work, okay? This one just give you an overview of the internet, okay? So today we give you the overview of the computer and the internet, and next week focus more on detail of the network protocols. Any questions so far? Any questions so far? If you haven't submitted the Unit 4, please submit, okay? I need to grade them, and then.
Oh wait, Mr. Chow.
Yes.
For some reason, I don't know if you fixed it, but I couldn't get into the website.
Yeah. From time to time, I fixed it 3-4 times, so
Okay.
it's on and off.
Okay.
And I talked to the who host the people. If you cannot have it go through, you can also send by email. Okay.
Okay. Thank you.
Oh, great. And that's not your problem, I know. This week we do experience the network problems. I talked to the who host for 3-4 times. Okay. Any other question?
No.
No? Okay, that's it for today, okay? Focus and finish the Q4, okay? The quiz number for chapter 4. There are some smaller quizzes that we have. You can also try, okay? Those are each is small units quizzes. Okay? If no question, that's it for today. Thank you. See you next time. Bye-bye.
Thank you.